EV landscape is shifting beneath our wheels, isn't it? As electric vehicles become, well, more commonplace, so does that constant quest for convenient charging. But what happens when the traditional grid isn't always an option? Or maybe you're just aiming to truly maximize your clean energy footprint. Today, we're diving deep into a really fascinating solution that addresses exactly that: the GoSun EV Solar Charger. We've managed to unearth a detailed analysis comparing it to other rooftop EV charging methods, along with a pretty thorough look at its economics.
Yeah, and our mission today really is to cut through the noise. We want to extract the most important nuggets of knowledge and insight from this material. We'll help you understand what makes GoSun unique, how it truly stacks up against the alternatives, and whether it's actually a smart investment for your specific needs. All without feeling too overwhelmed by the data, hopefully.
Okay, let's unpack this then. Our listener might be wondering, is this just another gimmick, or could it genuinely, change how I power my EV? Let's try and peel back the layers and see what GoSun is actually designed to do. So to kick us off, what exactly is the GoSun EV Solar Charger? We're talking about something you deploy, right? An external solution, something that works with your car, not built into it.
Exactly. Think of it like a portable, flexible energy source you can set up when you park. When it's fully deployed, meaning those solar panels are unfolded, it boasts a maximum output power of around 1,100 to 1,200 watts.
Okay.
It delivers level 1 AC charging through an inverter. Now, for those familiar, that's basically like plugging into a standard wall outlet. It's a steady charge, kind of a trickle charge.
Right, not a fast charge.
No, not at all. It's perfect for maximizing sun exposure over time, rather than getting a rapid fill-up. Its fold-out design means it's specifically intended for use only when your vehicle is parked. And importantly, it's universally compatible. It's designed to work via roof racks on, well, pretty much any EV out there.
So it really is a park and charge solution built for flexibility. What are its primary applications then? And what kind of, practical daily range can an EV owner actually expect from it?
Well, it's ideal for off-grid scenarios, definitely. Think campers out in remote areas, or maybe just for daily top-ups to extend your range without pulling from your home grid. In real-world conditions, you can probably expect it to deliver an average of maybe 10 to 20 miles of charge per day.
10 to 20 miles. Okay.
The unit itself costs approximately $2,999. It needs low maintenance, thankfully, limited moving parts, and it's likely eligible for a 30% U.S. tax credit, which is, a pretty significant factor for the cost.
Yeah, that definitely changes the math. That puts it in a very specific kind of sweet spot. Now let's talk about the competition. How does GoSun stack up against other ways people are trying to put solar on their EVs? I'm thinking of those integrated solar options like what you see on an Aptera or maybe a Lightyear Zero, and also those more DIY roof rack setups people sometimes tinker with.
Right, and this is where GoSun really carves out its own unique space. Let's look at those integrated rooftop solar options first, like you mentioned, the Aptera or Lightyear Zero. Their max output power is typically a bit lower, somewhere between 600 to 800 watts. They charge via DC, which is integrated directly into the vehicle's battery. That's generally more efficient.
More direct.
Yeah, exactly. And they're static, meaning they're non-deployable. They're just built right into the car's body.
And their compatibility is proprietary, right? You essentially have to buy that specific car to get the solar feature.
Precisely. They are built into specific proprietary models only. Their use cases are primarily for, say, commuters or those really ultralight solar-only EVs. They claim to deliver maybe 20 to 40 miles per day.
Okay, higher range claims there.
Yeah, but the cost, of course, is baked into the vehicle's price. You're looking anywhere from, $45,000 up to maybe $250,000. Maintenance is probably medium. Solar cells can degrade over time, but they're eligible for tax credits as part of the whole EV purchase.
So highly integrated, very efficient perhaps, but tied to a very specific and often very high-end vehicle. What about those DIY roof rack panels then? My gut tells me these would be a bit less robust, maybe less reliable.
You're absolutely right.
Yeah.
Yeah, DIY roof rack panels, they typically have a max output power of only like 300 to 600 watts, often less. Their charging mode varies wildly. Often it's just a trickle charge or maybe designed just to power USB devices, auxiliary batteries, not really for meaningful EV propulsion.
Right, just keeping accessories topped up.
Pretty much. Like the integrated options, they're static, roof-mounted, and vehicle compatibility. It varies hugely because it's all DIY, improvisational stuff. They're mainly for hobbyists, maybe an emergency backup, but they deliver maybe 1 to 5 miles per day, if that.
Just a handful of miles.
Yeah. The cost is much lower, maybe $500 to $1,500 for parts, but maintenance is high. They're often described as fragile, unregulated. You're dealing with components not really designed for the rigors of being on a vehicle, exposed to the elements. It leads to unreliable performance, frequent issues.
Makes sense.
And they're often not eligible for tax credits either.
Okay. After seeing how GoSun stacks up against those extremes, it becomes pretty clear it's carving out a very unique space, doesn't it? What's the sort of ultimate verdict on where GoSun truly excels in this, well, kind of crowded field?
Yeah, I think the verdict is that GoSun strikes a really compelling balance. It offers a good mix of affordability, especially with the tax credit solid power output for its class, and crucially, that universal compatibility.
Hmm.
The built-in solar EVs, they're highly efficient, yes, absolutely, but they are largely inaccessible to the majority of EV owners, just too specialized, too expensive.
Right.
And those DIY panels, well, they generally lack the efficiency, the scalability, or frankly, the reliability to provide meaningful EV charging. So GoSun sits right in that sweet spot in the middle. It offers a practical, deployable solution for a much, much wider audience.
Now, here's where the rubber really meets the road for many of our listeners, the economics. Let's talk dollars and cents, specifically the cost per mile.
Okay, so to analyze this, we established a few core assumptions first. We assumed an average EV efficiency of about 4 miles per kilowatt hour.
Pretty standard.
Yeah, pretty typical. A GoSun daily output of approximately 3.5 kilowatt hours per day, assuming good sun conditions, of course, and the current average U.S. electricity price of around 15 cents per kilowatt hour.
Okay.
For the GoSun unit itself, we factored in that upfront cost of $2,999, which then reduces to about $2,100 after applying that assumed 30% U.S. tax credit.
Right. And what's our baseline for comparison? What does it typically cost to charge from the grid with those same assumptions, just plugging in at home?
Based on those numbers, yeah, grid charging typically costs about 0.0375 per mile. So just under 4 cents a mile. That's a reference point.
Okay, under 4 cents. Got it. Now let's crunch the numbers for GoSun. How does that cost per mile evolve as you use it over time? This is where the long-term investment aspect really starts to show itself, I imagine.
Indeed. It really does. If you look at the effective cost per mile, it changes significantly over the years. Think of it this way. For the first year, you're essentially investing in your energy independence. It's almost like prepaying for your fuel. At that point, the effective cost per mile for GoSun is approximately $0.41. So quite a bit higher than the grid initially.
41 cents versus 4 cents. Yeah, that's a big difference up front.
It is. But that drops considerably as you continue to use it and amortize that initial cost over the free energy you're generating. After 3 years, it's down to about $0.14 per mile.
Okay, getting closer.
Extend that to 5 years, and it's roughly $0.08 per mile. Get much more competitive.
8 cents?
And then finally, after about 10 years of consistent use, it approaches grid rates. It gets down to about 0.041 cents per mile, so very close to that grid baseline.
10 years? That feels like a long time horizon for many buyers, doesn't it? How do you respond to someone who says, look, I'm not sure I'll even own this car, let alone this charger, in a decade? What's the actual break-even point where GoSun starts to truly compete with grid charging, just purely from a financial perspective?
That's a really fair point, and it absolutely highlights the long-term nature of this kind of investment. From a purely cost-per-mile standpoint, yes, it does take approximately 10 years of consistent use for GoSun to effectively match current grid electricity rates. It's important to be upfront about that. For the first, maybe 5 years or more, GoSun is more expensive per mile than simply plugging into the grid.
Okay.
However, somewhere after that 7 to 10 year mark, depending on usage and sun exposure, it becomes genuinely cost competitive. Because at that point, the sunlight becomes essentially free, right? You've paid off the hardware costs through the energy generated, plus you have to consider the increasing value of its resilience, which we haven't even factored into the cost per mile yet. So yeah, it's definitely a strategic long-term play.
That's a powerful way to frame it. It's not just about the cents per mile today. Okay, so beyond the direct financial costs, what other, maybe less tangible, but equally important benefits does the GoSun EV Solar Charger offer?
Right. There are several really compelling intangible benefits. These often address needs beyond just saving money immediately. First, there's energy resilience. That's a big one. It provides significant independence from grid access that makes it excellent for remote users, or maybe just those preparing for potential power outages.
Peace of mind.
Exactly. Second, the environmental impact is pretty profound. You're utilizing a pure renewable source that leads to genuinely zero-emission driving for the miles generated. Third, there's a potential benefit to battery health. Slower charging rates, like those provided by GoSun's Level 1 charging, may contribute to reduced EV battery degradation over time compared to, say, freaking DC fast charging.
That's fascinating and often overlooked, isn't it? Extending your battery's life just through the charging method. Are there other less obvious perks we should be thinking about here?
Absolutely. It also contributes to overall grid load reduction. I mean, by charging your EV with solar during the day, you're helping to lower demand spikes during peak times. Think heat waves, potential blackouts.
Yeah.
You're doing your little bit.
Right, less strain on the system.
Yeah. Plus, its inherent portability is a huge asset. The unit isn't tied to one car. It can be transferred and used with another vehicle, maybe even an RV, which adds to its versatility over its lifespan. And finally, if you maintain it well, the unit itself might retain some partial resale value. It's not insignificant.
Those are certainly compelling points, especially for certain use cases.
Right.
But let me just play devil's advocate for a second. Are there any sort of downsides or hidden complexities to these intangible benefits? For instance, you mentioned portability. Does that mean it's something you're realistically lugging around daily, or is it more of a set it and forget it at your destination?
That's an excellent question. No, it's definitely not designed for daily setup and takedown. It's meant to be deployed when you're parked for extended periods, say at a campsite for a weekend, or maybe a vacation home for a week. So for a daily city commuter, that portability benefit might be less of a practical factor than for someone who takes long road trips or camps frequently.
Got it. And what about the environmental footprint of actually manufacturing and eventually disposing of the unit itself? Is that factored in?
Another good point. Like any manufactured product, there's obviously an embodied energy cost in its creation. Solar panels, inverters, they all take energy to make. However, considering its expected long lifespan and the significant amount of fossil fuel-generated electricity it offsets over maybe 10, 15, 20 years, the consensus is generally that the lifetime environmental benefits far outweigh that initial manufacturing impact.
Right, the long-term payoff. Okay, so connecting these benefits back to our listener then, for whom might these strategic values be the most compelling reasons to seriously consider GoSun? Who does this really speak to?
Well, I think these strategic values become most compelling, depending heavily on your lifestyle and priorities. If you're a daily commuter just looking to offset some of your grid electricity use, maybe trim that bill a bit, then the long-term savings and the environmental benefits could be very appealing.
Mm-hmm.
If you're more of an adventurer, someone who frequently takes their EV off-grid for camping or remote trips, then the energy resilience and independence are absolutely paramount.
Oh.
I mean, you could just picture it, right?
Yeah.
Being out somewhere remote, low on charge, this GoSun becomes an absolute lifeline.
Yeah, that's a game changer in that scenario.
Totally. And then for anyone interested in preparedness, reducing reliance on centralized infrastructure, the ability to generate your own vehicle's power, especially during grid outages, offers really significant peace of mind. It really makes you think about how much we value that grid independence, or rather, how much we take it for granted until the power goes out, doesn't it?
It really does.
So to bring it all together, what we've really seen here is that the GoSun EV Solar Charger isn't designed to be a substitute for, say, fast charging or even daily full EV charging from the grid. That's not its purpose. Instead, it clearly shines as a really effective top-up solution or as an essential off-grid power source. That's its niche.
Yeah, this deep dive really highlights that. For those commuters looking to offset some grid use, or the adventurers seeking freedom, or maybe those just focused on preparedness, GoSun seems to offer a compelling package. It blends long-term savings, crucial independence, and yeah, a good dose of peace of mind. But remember, as we discussed, from that pure cost per mile perspective, it truly starts to break even with grid charging somewhere between year 7 and year 10, depending on your usage and local electricity rates. So this isn't necessarily an instant financial win. It kind of challenges our short-term thinking, I think. It forces us to consider that longer-term economic curve, especially as grid costs might fluctuate and the value of self-sufficiency potentially climbs.
And that raises a really important final question for you, the listener, to consider. As our world continues this shift towards renewable energy, and maybe as grid stability becomes, well, a growing concern in some areas, how might the value of energy independence offered by a solution like GoSun evolve? How might it change beyond just its monetary break-even point? What might be the true cost, or perhaps the true benefit, of not relying solely on the grid for your vehicle's power in the years and decades to come? Something to think about.
Definitely something to think about. What does this mean for your own EV journey? We really hope this deep dive has given you a shortcut to being well-informed on this exciting piece of technology.